We've looked at stateless transformations on D streams, which are fairly simple to understand given our previous understanding of RDD transformations. Now let's look at stateful transformations, which are just a little bit more complex. Stateful transformations combine data across multiple batches in a D stream, in some cases, which we'll see in these examples, by maintaining state that gets added to the computation between batches that are processed. Let's take a look at the primary API that we have for this. We've got one new method called UpdateStateByKey. Now this expects to be working on key value pair D streams. We pass a function to it that's a little bit more complex than most of the functions that we've been passing into our transformations so far. This function takes two parameters. One is a sequence of values, which are all the values in that batch for a given key. So this function is going to get called by Spark for each key in the batch. The second parameter that the function takes is the current state. The function will then return a new state value based on whatever computation it does internally. Now, for UpdateStateByKey to work, we have an important qualification here. Checkpointing has to be enabled. What checkpointing does is, on a periodic basis, it's going to persist all the Spark metadata to a file system. So you'll configure the directory where that stuff gets written, and in DSE that's going to be a CFS directory, and Spark will persist all that metadata there periodically. This is important since this streaming job could run for a long period of time. We want to persist the state metadata on some regular interval, so if there is a failure, we don't have too much recomputation to work. Without checkpointing, Spark would have to recompute the entire history of the computation from when the job started to the present time, and of course that's not practical. Let's have a look at an example of a streaming job where we might use state. Again, we're going to start with a diagram, very abstract, then we'll move to the code. Looking at what's going on here, we have a receiver bringing in data. These are, again, IDs, probably movie IDs from our movie database. The first thing we're going to do is we're going to run a transformation called count by value. That's going to group up like keys and give us a key value pair of each key and the number of times we see that key occur in that batch. Then we want to aggregate those counts. So far that stream is just going to show us a count of how many times each key occurred during the last batch, but we'd like a total running count. So for that we'll use UpdateStateByKey, which we show on the bottom. Notice how the two batches come in with counts of 10 and 8 and 4 and 2. You can go ahead and pause the video and check that those IDs are identical. They are. We want a running total of all of those counts, which we see in the box at lower left, which is 14 and 10. That's the count across the whole stream, not just one batch in the stream. Let's walk through the code that gets the job done that we just saw in the diagram. Now the code block at the top is the actual function we're going to pass into UpdateStateByKey. Up till now, all the functions we've passed into Spark methods that take functions have been anonymous because they've been pretty short, kind of trivial things. In this case, though, it seems like it's a complex enough thing that we want to give it a life of its own and a name. And that name is UpdateMovieCount. It takes two parameters, a sequence of values, and the old count, or the state that we've maintained from previous invocations of this function on previous batches, previous RDDs in the D stream. It performs a little bit of logic there, essentially adding the new values to the existing state and returns the new state, the new count, as essentially a scalar value. Then the code below is the Spark application itself. We create a new streaming context. We open up a text stream to our stream of movie IDs, and then we count by value on that stream, turning it into a pair RDD, which is what UpdateStateByKey needs. Then we call UpdateStateByKey, passing in the identifier UpdateMovieCount, which is the name of the function we wrote up above. Finally, we print the result, and we're done. The sample output looks pretty clean. You may need to pause the video and kind of sort through this, make sure it all makes sense. I encourage you to pay attention to the timestamp, and you'll see that it changes by 4,000 milliseconds because our time is 4 seconds, and see that the counts are actually incrementing for unique IDs. We'll see at the top there 467. In the next stream, it appears to be 469. 470 becomes 471, and so forth. So there is a very simple Spark application using stateful transformations.